My name is Brian Douglas, and I am a developer advocate here at GitHub. GitHub is a developer company, and we make it easy for developers to be developers, to work together to solve challenging problems to create the world's most important technologies. And within the last year, we created this new tool to help that creation and collaboration, which is GitHub Actions. In this video, we're going to cover 4 things. 1 is, what are GitHub Actions? 2, how to leverage GitHub Actions today. 3, building your own GitHub Actions. And then finally, we're going to walk through continuous integration and continuous delivery into the Azure portal for a .NET Core app. So what are GitHub Actions? GitHub Actions is a tool to automate all your software workflows. You can build, test, and deploy your code right from GitHub. I'm going to jump right into an example of me using a GitHub action for a project I'm working on today. So here we're in my organization, which is GitHub Craftwork. This is the place I host all my workshop and tutorial content. And I want to show you how I leverage a GitHub action to invite new members to the organization. And the best part about the solution is that none of my attendees have to know anything about GitHub Actions to invite themselves to the repository. The way I do this is by creating a GitHub issue where I instruct the attendees to type in, invite me. Now the .invite is a special keyword that I built inside of my action. If I go over to my Actions tab in my repo, you can see the GitHub action workflow has already started. And then in a matter of seconds, you can see the action's already completed. And if I go and check back to my organization, I can see my invitations waiting for me thanks to that GitHub action. Let me go ahead and click join. And now let me show you how this action was made. Now every action is installed onto a repo using a YAML file. These YAML files will live inside of a workflows folder under the .github directory. This syntax might look self-explanatory, but I do want to point out that this workflow is running on the issue comment event. For all workflows, GitHub Action workflows, they have jobs, and those jobs can have a unique ID. Here we're also naming our job, prepare invite for new contributor. The best thing about actions is you can actually leverage GitHub repos to power those actions. Here you can see we're using actions checkout master, which looks like this. Also, I'm going to make a call out that the actions file, is being powered by code directly from this repo in the actions folder. Let's take a look at and see what that code looks like. It's using the OctaKit library for accessing the GitHub API. Here I'm doing a simple conditional to check to see if invite me was included or if the GitHub handle was included. And then from there, I'm leveraging the team ID that I already have stored into an environment variable to send that invitation. So now you've seen this GitHub action and how this GitHub action works. Let's head back to the slides. So here I'm back in my organization that we had already seen, and I've already gone through the liberty of creating a template for my new Hello World GitHub action. I'm going to give my repository a name and then provide a brief description for it. Once everything looks good, I'll create that repository, and here we are. Now that template already provided me a workflow folder and a Hello World GitHub action. So let's take a look at that. Here you find the hello.yaml file, which is going to be my workflow. And here you have a simple GitHub action ready to run. Now because I installed a template, every time I push to this repository, the action is going to fire. So you can see that on push event on the line 1. And the simple thing that's going to be doing is echoing hello in my logs. So let's go check out the logs. You can find the logs by clicking on the Actions tab in your repo. You'll see my first workflow is already run. Within the workflow, you can click through to see the logs. And you'll see hello being echoed directly in the logs. Pretty simple. Also want to point out that you could actually view the logs either by downloading a zip or view the raw logs directly in browser. Also want to point out you can do timestamps as well. Viewing the raw logs is going to be super helpful for debugging. If you need to find a certain line, you can leverage it that way. So inside this workflow folder, I'm going to walk through. Again, we already have the push event. We talked about that. We have a name for our action. We have the jobs. We do have the unique ID, which is the build. That can be named anything. I'm also naming it so it's printed in my logs as Hello World Action. Running down the list on line number 6, I'm running a Ubuntu VM for this because that's the one I'm most familiar with in writing bash scripts. If you look below the steps, which are going to be synchronous workflows, right at the moment I only just have one, I'm simply just echoing hello. And that's as much bash as I know. But what I do know is I could actually add some more bash. So I'm going to add an environment variable that's given to me for free through the GitHub Actions. Now there's a number of these variables, which we'll take a look at in a second, but I'm going to edit that and add that there. While that's being committed, let's take a look at the documentation for where GitHub Actor is located. GitHub Actor is one of the many environment variables you have access to, so please check out the help documentation for more environment variables that you can leverage. Now let's head back to our repo to see how the commits landed. Now that I've committed, you can now see this GitHub action hello world. Now that we check our logs, we can see our last workflow was already triggered by our last commit. It's not only just run, it's also printing the name of my handle, which is I'm the GitHub actor. I've been the actor the whole time. To start the continuous integration process, I will start with the GitHub repo, as you can see here. Next, I'm going to set up my GitHub remotes locally with my .NET Core app. Now that the remote's set, I'm going to leverage Git to push my code up to GitHub. Now, if you're not familiar with Git and the Git commands I'm using, please leverage our lab courses and training materials in the GitHub documentation. I've already set up a .NET Core app locally in my environment on my desktop. So now I'm just going to go back and set my Git remote and push that directly to GitHub. Once everything's been pushed up to GitHub, I'll go back to the web interface and add my first workflow. Now, so far we've been hanging out in the Actions tab, so there's no reason not to go back there. If you want to wear the Action tabs up here in our repo, And since we have no actions set up, it's going to present us with this array of actions to choose from. Now, for the most part, GitHub's going to make the decision or make a guess on what type of code we have in our repository. It already knows that I'm using .NET Core, and it's going to allow me to just click one button to add a workflow. Now, as we've seen before, these workflow files are just YAML files that live within the .github directory and in the workflows folder. This workflow is going to not only run the build command, but it's also going to run CI and testing for us locally within the GitHub environment inside of our repo. It's going to take a quick check. Also want to point out that we're using event workflows for push and pull requests, which is new. Also going to point out that we do have a unique job, which is going to be called build, and we're running this on the Ubuntu image. Now, this is the first time we see synchronous steps within our steps flag. So the first one's going to be the actions checkout. Actions checkout is going to be a third-party action, a community action, as I mentioned before. And this to prove that, I'm going to show you the repo, which is a simple GitHub repo that is built as a community action. Next community action is going to be the setup.net. Now, this is a community action that's open source and supported by the community. So if you have any experience in .NET or if you have any questions on how this is set up, please go in the issues and feel free to open up pull requests. Contributions are welcomed. Finally, let's go back to our workflow file and get that thing committed. I do want to call out that we're using .NET version 3.1.101 locally, but in my environment, I'm using 3.201. You always want to make sure you're checking to see if you're using the correct version. So I'm going to check it and make sure here. Yep, 3.1.201. So since I have a different version, I'm going to go ahead and update that argument for the .NET version, the 3.1.201. Everything else looks good. So let's go ahead and get this file committed. I do want to point out while we're here, on the right pan, there are other actions, third-party and community actions, that are hosted on the marketplace that are being shared directly in this doc sidebar. Feel free to check out those actions if you see anything that are interesting to try out for your project. Now, I've went ahead and just committed directly to master without doing a pull request, but because I've done so, as you remember back in the workflow file, we're running this workflow on every push event to the master branch. We already see that the action and the workflow has already been running. So let's go ahead and check out the logs. Excellent. The entire build is run, and we have only green check marks. That's a good sign. Everything's passed. Let's go back and check out the workflow folder. So now that we have CI enabled on our repo, there's one other thing we have to do, which is add continuous delivery onto our project. Because we want to deploy these directly to Azure once all tests have been completed and CIs and the build has been processed. Now, we do have a choice to deploy directly to Azure using a GitHub action, but this GitHub action that's recommended here is going to be a Node.js. Instead, I'm going to go back to our Azure portal and click back into our web app. I've already done the work to set up my Azure portal with a resource group, and I already know that I'm going to be using .NET Core, so I'll select that too as well. Finally, I'm going to choose Linux because that's what I'm familiar with for debugging purposes, and I'm going to review and validate that resource. Looks like I had an error. Let me go back. Oh, turns out I forgot to put a name for my repo. Let me just grab my repo name, paste that in, and proceed to the validation of my Azure resource. Everything's been validated, so let me create the Azure resource and initialize my deployment. One thing I want to point out is that inside your Azure YAML, you will need to update your Azure Web App name. But there's a way to make this easier. There's a way to make it easier and not have to fiddle with editing YAML files, which is actually leveraging this directly from the Azure portal. So let's head back to the Azure portal. We see our resource has already been deployed and set up. Now this resource is going to be empty. We haven't actually connected this to our GitHub repo. So if you go to the deployment center within the Azure portal, you'll see a nice convenient little box which says GitHub Action Preview. Connect GitHub to your Azure resource, which will give you access to the repository. Finally, click the GitHub Actions Preview, so that way we can leverage GitHub Actions on the repository to set up continuous delivery for Azure. You will need to select your organization, which for this case, it's going to be my handle. You will also need to find your repository and select that. And then finally, check the branch that you want to continuously deploy to Azure every time the task is passed. In my case, it's going to be master. And since I already have GitHub Actions installed and set up on my project, I'm just going to configure and update my existing workflow. Once everything looks good, click that finish button, and it will trigger our next deploy. It'll take a few seconds for that deploy to spin up and finish. Now, because I've connected my project to Azure and I have continuous delivery and continuous integration, I'm going to make a super small change to the title of my page just to see this working. I'm going to leverage GitHub's in-browser editor, and instead of saying welcome, I'm going to say welcome world. Because why not? Instead of committing this directly to master, I'm going to commit this to a PR because I want to make sure that all this works. Best practice is leaving a nice descriptive PR description, which I'm doing so now. Now that the pull request is open, it should go ahead and trigger CI based on my workflow. Remember, I'm checking for 2 events, which is going to be push and pull request. Notice in the status checkbox, it does say pull request as the event. Heading back to the logs, we can confirm that everything's been green, it's checked, and it's running right in order. And because that worked, we can actually check to see in the Azure portal if our deploy updated. And from giving it a quick refresh, you could see it did. Welcome world. Now I'm sure you learned a few things about actions today, but as a reminder, we learned what are GitHub Actions, how to leverage GitHub Actions today, building your own actions, and leveraging actions with CI and CD today. I'm Brian Douglas. You can find me on Twitter at bduckeo, as well as email me at bduggy@github.com. Happy hacking.